Okay, this is the first video. I will start with you regarding ENG 205 numerical system. I find out that the fixed point iteration is a bit confusing. Fixed point iteration is a bit confusing, so I'll try to demonstrate it too and how you deal with equations regarding the fixed point. Okay. So basically, the fixed point method that's given a function of x is equal a function of x, and y equal x. So if we look at that, okay, what we have, a function, x is a function of x, and y is equal x. So what we're trying to do, to draw two lines and the curve. You see, so this is the curve is function of x, and this is y, x. And in this graph here, you may have 2 points, point 1 and point 2, and this is x1 and x2. So we want to find these 2 points, the solution of function of x equal x and y equal x. It has two solutions for in this figure, x1 and x2. So how we find out x1 and x2? We know, the condition that derivative of f with respect to x absolute must equal to 1. So that's the condition for stability. So this is condition of convergence. So this is a condition of convergence. I'll show you in MATLAB how you try to achieve that. If you look at this figure, for example, here, at point x1 here, or at point p1, you see the derivative of the function is greater than 1. So we won't be able to obtain x1 because it will divert. It will not converge at this point. But we'll be able to find out x2 because the slope of the function with respect to x at point p2 is less than 1. So if we start anywhere below x1, it will diverge. If we start anywhere between p1 and p2, according to this graph, it will convert to point p2. And if we start at a value greater than x2 here, it will come back and converge back to p2. I'll show you how we will we can obtain p2, point p2, and how we scale or change the function to obtain p1, because in S form here we'll not be able to obtain p1. So let's do it on the computer, on the laptop. Okay. I have what I will do. I will put a vector of x from 0 to 10. Okay, and let's see a function. I'll call it f1. F1, I'll write it down for you also. F1 is, as you see it, F1 is equal 1 over x, 1 over 6, x squared plus 4 over 3 minus 1 over x plus 4. So this is equal x. Okay, here we have a function. That function f1 is equal to x, and s equal 1 over 6 x squared plus 4 over 3 minus 1 over x plus 4. Okay, so let's sketch this function and see how it looks like. Okay, this is the function 1. I want to plot, okay, I will plot, I'll plot x1, you see here, x and y, but we have not defined y yet, so let's define y as it is equal x. Y is equal x, so we have f1 and y1. Let's plot. Plot x and y and x and f1, our function. We'll plot x and y in a k, which is color of black color, and let's plot f1 in a red color, and I'll remove this for the time being. I'll show you how to do that later on, and let's plot it and see what it looks like. If you look at this graph, let's be enlarge it. If you look at this graph, this is f1 here, and this is y equal x. So you see from the graph that we have 2 points. This point here, okay, this point here, and the other point is this one. And here we have x is between 1 and 2, but we don't know it. And in the other point we have x is between 4 and 5, but we need to calculate it. Okay, so once I see from this figure, the way I see it, I will be able to obtain a solution. This solution will be able, because we start below that point, say at 1 or at 0.5, it will convert to that point. And if we start above that also, it will convert to this point. Okay, no matter where you start. If you start just below this x2 here, it will convert this one. And if we start our iterations above this point, say at 5, it will divert. Will not be able to obtain this solution. So we'll be having a problem in the solution. So let's start finding out at least this value here. Let's start at 0.5 and see what we will get. We'll call it another variable, x equal x1. I will start at 0.5. At 0.5. Fine. And according to that, I will find what is ff, the same function, but 1. Okay, that's the same function. 1 over x squared, so x, let me change this one to 1. That's the first point. 1, and here also 1. The same function exactly, but I will find out what is the value of function 1 when x is 0.5. Okay, fine. So we find out that one. Now we'll do some iterations. Let's say 10 iterations for k. Okay, k equal to 10. Why we start at 2? Because already we have calculated x and f at iteration number 1. So we'll start at 2. At 2, we want to find the value of x. It was 0.5, but let's update x as it is called the same function, the same previous function, because they are equal. Okay, so here it means that xx at 2 is equal ff at 1, and ff at 1, okay, that's the value of what we have already calculated that. So this is this. Let's calculate ffk. Now it's k, but let me change. Okay, that's k. This is let us make sure that it's the same function. Yes. That's the same function, and we end that. Now we want to draw it. If we want to see xx, I will just write the transpose as a column vector. So we started at 0.5. It's increased, and it's approaching the solution, you see? The same for ff, okay? It's approaching the solution. So you see this figure here and this figure almost the same. We want to sketch that on our graphs. So what I will do, you remember that we start each point with x, 2 points, as if you see here. We start here, somewhere here, okay? Anywhere. So we start at the line y over x, and at the same point here, we go to the function. So we have two values of the function. One is y, one f, but at the same point x. So for each point, each x, okay, will have two values. And when it goes horizontal, then we have for the same function, same value of the function, but we have two. So I'll show you just on the graph. So we can do it that way. Let's say x naught. I will define x naught as xx, two values, but belongs to the first iteration or the first point. Let's say this is x or x naught, okay? And f naught is equal, okay, you practice that. One value, which was the previous one, which was at xx1, and this value f of 1, okay, that belongs to the same point that we have calculated f. I'll show you on the graph how we proceed. Now, we want to go for the same iterations, f, but just update that. Now we'll update x naught, okay, but the previous x naught, and now the new k, okay, xxa 2 points, exactly the same, okay? And if not, we can do it also the same way. If not, you see that we put a value of xx because it's supposed to be the same function when we say y equals x, and then the new value obtained from the function, and then we end that. Okay, so let's plot it. Plot the previous one, xy and xf. You look at it again. This is x, y, and xf. Now we'll plot the iterations with it. Okay, let's see how we plot the iterations. This is right. Let's plot it. X naught, f naught, and let's give it another color. So we have here black. We have this k. K means it's black. R is red. And let me give it color blue. Okay, blue. Okay, so this is blue color. Okay, let's look at it. We started at 0.5 here, so it goes to this point, then this point, then this point, this point, this point. So it's approaching, okay, approaching the solution. Okay, so if I sketch it here, let me just do it on the paper a little bit, something like that. Okay, this is y equal x, and this is our function. Okay, so here what we have, function 1 of x. Okay, that's what we have here. So if we start somewhere at 0.5 here, it will go like this, and so on. You see the arrows, how I sketch it. There will be an arrow going from this point to this point and continuing again. Okay, so that's why I sketch it more. Okay, and here what we have, we started here, then it goes like this, it comes like this, and goes up. As if you see it like this, it will be like this. Okay, but I don't know really how to sketch that arrow on this. Probably you learn how to do an arrow here, and then you teach me that. Okay. So this is that. So we are happy that it's converging, okay, to that point. Let's see it. If we want to find out what is the tolerance of that convergence, what we have is x naught, and we have f naught. Okay, so you see the final. Let's find out what is f naught, the final value, which is n. You say just end here, it will give you the final value, this value. Okay, and let's subtract it from minus x naught, the final value end. Okay, you get the tolerance is 0.0012. Okay, as if you see it, you can enlarge it. But if you want to reduce that tolerance, what you need is just increase the iteration. Remember, we have done only 10 iterations. I'll repeat that for 20 iterations, and I'll show you how you do that. Let's say x1 equals start 0.5, and if f1 also the same way how we calculated that. And now for instead of going to 10 iterations, let's go to 20 iterations. Now we repeat the same xx, same procedure, xxk, okay, then ffk, okay, and we end that, okay, and we do the same x naught, the previous one, x naught. First we start this one, then f naught, we start the first iteration, okay, first iteration, that's the one. Then we repeat the loop, we make the loop from 2 to 20, okay, and then we find x naught, okay, and then we find f naught, okay, this one, yes, that's correct. And then we end that iterations, and let's plot it again. Okay, plot it again. You see here that you have, okay, it's approaching here more. Okay, you can expand that points here. Okay, but let's see the tolerance. If not, that one. Okay, end minus. You see the tolerance has gone to 10 to the minus 6. So we are happy finding the final value, that's x naught end. This is the one of the solution which belongs to plot. Okay, it belongs to this point here. Okay, you can also draw it with a grid. You say just the grid here. Okay, see better how it looks like. Okay, may help you. You can enlarge it more, expand it, and draw it, or from 0 to 3, for example. You can do that. Now the problem is with this point. But let's start somewhere between here at 4, for example. Okay, and see how it will come back to this point. It will not go to that point. Okay, let's start x1. Instead of 0.5, we start at 4. Okay, we do the same for f of 1. Okay, f of 1. Now we do a for loop. Let's go to 20. It's okay, no problem. And now xx is k is equal to the previous of the function. That's when we move horizontal from the function line. So once we first we start this one, then we come to the function, then we move horizontal Okay? So xx, the new one, is the previous of that f value. So we started this way, and then if came, yes, okay, and then we end that. Now we go to defining that x naught first, okay, and if not, the first iteration, okay, then we do the same looping for k20, and we update x naught by taking that vector and adding to that vector these two values, okay, and we do the same for f naught. We update it, okay, that's the one, and then we end that, and let's plot it. See, let's enlarge it. So we started at 4 here, at this point here. Then from that point we come to this function, then horizontal, then vertical, then horizontal, and then vertical, and so on, until we reach this stable point. We call it a stable point, the point that the solution converts this. So it doesn't go to the near one, to the 4 point something. It will never go there, okay? And let's see what is x naught end. Okay, so that's the same solution of the previous one. We compare it, okay? We go, so 1.5, okay, x naught end, and x naught 1.559, 1.557. We, here probably it needs more iterations to reach the same value. Now, let's start, let me plot it, just see where we want to start now and check. Let's start somewhere above this point. Let's say in 5, okay, start 5. But we need not to go to 20 iterations, only 10 iterations to show you that it converts there. It diverges, it will not converge. Let's start xx at, instead of 4, we say 5, right? 5. Then we find ff the same way, 1, okay, and then we do for loop. We don't need to go to let's go to 20, no problem. Then we find, we do the same exactly, okay, and ff, okay, and in that, okay. The reason I'm showing that I'm going to 20, you'll see that you have huge figures. It will diverge, you know, but I will show you how to draw the thing that you need to know. Okay. Now let's do the same for x naught. This is the initial. F naught is the initial, 2 points. Okay. And then do the loop again for, do the iterations for k equal 2 to 20. Let's define x naught, update the vector x naught, okay? And update the vector f naught, okay? That's correct. And end that. And let's plot it. Plot the same. You see here, you have a problem. 10 to the 5, 8. Why? Because if you look at x naught, it's going to infinity. If you look at f naught, also it's going, so it's diverging. So instead of that, what we do, we plot not all of them, plot x naught, say 1 to 5. 1 to 5. And if not, also 1 to 5, and see how it looks like. You see, even if you go to 10, we started at 5 here. Just enlarge it. We started at 5 here, okay? Go vertical, then horizontal, then vertical. So it's diverging, it's not coming. The reason is why, because the derivative here of the function is greater than 1. So we will not be able to obtain that solution. The solution at this point will not be able to find it unless we modify this curve. Now I'll show you how we do that. Okay. Hope it is you can see it from this video. Okay, because I cannot enlarge it, but you try to probably you can modify it. You can expand this video probably a little. Okay. Now. This is the basic idea. I want you to practice that, go through this example, practice it, okay? Now, I'll show you how we update that. This point here, okay, diverge, and this point here, converge. You look at it here, at this point here, it diverges, while at this point here, it converges. We are able to find the solution at this point here, but not here. What we will try to do to reverse this one. So make this loop here greater than 1 and reduce this loop here less than 1. What we will do, this is f1, x equal f1. The first modification we will do the same, minus x equal minus f1. Minus x is equal minus f1. So we are reversing the function, but we have here minus x now. Add 2x both sides, so you get 2x minus x equal minus f1 plus 2x. So what we have done, just multiplied first by minus two sides, then we add 2x to those sides to obtain x here. So we'll find that x equal minus f1 plus 2x. And this, say this is f2. Okay? So we modify the function from f1 to f2. It's the same. X equal f2 now. Okay? Let's do it and see how the shape of the curve will change. Okay, so what I need is just to let's go to f1. Okay, that's f1. Let me call this f2, which is equal, we can say simply because we have calculated already f1, so it is minus f1 minus f1. Okay, but we add to that plus, okay, plus 2 times x, so that's f2. Now will our iterations will be on function 2, not function 1. Okay, let me sketch function 2, plot, and instead of that, okay, f2. You see now what happens? We have changed f1 to f2. Now this point here will become unstable, but we have found already the solution for this point. Now this is the unstable point where if we start here, it will diverge. If it starts anywhere here, it will come to this point. That's what we want. And if we start anywhere greater, like 5 here, it will come back to this node. It will not diverge. So this now, which was unstable, this point, now became stable point. So convergence will be achieved at this point here. Let's do it the same. I want to sketch both curves on the same. So here let's have f1, the previous one, f1, and now and here. And f2 here, let's make this as blue, okay? So you have these two functions. This is the original one, the red color is the original one. We had a problem at this point here, but we were able to find the solution at this point. The modified function f2 you see, the solution, it has the same 2 points, but now the first point became unstable and the second point became stable. So we have used F1 to obtain this point. Now we'll use F2 to obtain this point, okay? And we can start first at point 5 and or at anywhere below this one, at 1 for example, it will diverge, okay? Show you how. Now, let's go and do the same, equal, okay, x1, what is this, xx. Let's start at let's say 1.5, okay? If we plot, where's the, let's see, where's the point? 1.5 is somewhere here, but below the solution. I'm sure that it will diverge. It will not go to that, okay? And we find also F1, but be careful here. This was for the F1, but we have multiplied this by minus, you remember? We have multiplied this by minus, so we modify it minus, and we added 2 plus 2 times xx1. Okay, that's the correct one. So we have f of 1 and x1. Now we can find out the iterations. Now xx, we do the same process. F, okay. Remember this again, it's multiplied by minus here. Let's modify it. And we add 2 times, now xx, not 1k, xx, k, okay? And we end our solution. Now we do the same for x0 and update it. Okay, that is the one. And if not, update it. Okay, then we do the iterations 2 to 20, x0, we update that. If not, also we update it. Okay, and into that loop, and let's plot it. Plot the previous one. Okay, instead of f1 here, we have f2, and let's say just only 1 to 5, okay? Correct. I don't see f2. Let's see what's the problem with it, because it start at 1.5, right? Maybe 1.5 is a solution. Let's see what is x0. We have a problem there. Let's see. No, up, you see, we had a problem. It has gone very يعني just only same for it, not it jumped. We cannot see it in on the graph. Let's see, plot. Okay, 1 to 2. Even at that 2, we can't find it. Let's see what is x0. The first one, 1.5. The second, 1.5. The third, 1.47. It's reducing, right? And the third, It will be the same. Well, it will be the same. But the problem with F, okay, let's go to 5. Okay, okay. Let's see F. Maybe you have done a mistake. It's okay. What is this here? Let's see. X naught, F naught. Okay. Maybe we need to go to more points. Okay, that's why probably we don't see it here. Let's do it up. Okay. Plot. Okay, plot 1 to 2. Let's go 1 to. Before doing that, what we can see, what is x naught? Okay, let's say 1 to 10. Okay, that's fine. It's reducing. It means it's diverging. Okay, 220. It's going to negative. Let's do F for F naught. F naught is going also to negative. Okay. Let's do it for 1 to 10. From 1.5 to 1.2. Okay. And then let's do it for F naught. Okay, it's reducing, so it should be, we should be able to find out this F naught. Let's say 10, and here 10. Want to know why we don't see it there? Now we see it, right? What's this? You see it. You see it here, right? Can you see it? Okay. You see it here. Okay. It goes, and if we draw it for more than that, let's see. Let's say 15 and 15. Now you see, you can see it further. Okay. It's obvious here, right? It's diverging. We start at 1.5. You see, it's diverging. It's going. Let me just bring this. Can you see it now? Better? Yeah. Okay. Now we'll start at 2. It should go to the other point. Okay. Let's start at XX 1 at 2 or 2.5, doesn't matter. Okay, and FF1, okay, and do the loop 2 to 20, and find XX, update XX, update FF, okay, okay, right, and in that loop, okay, and now we do the same for X naught. X naught, we do the same for F naught. I want you to practice that and how you do it to update it and sketch it, but try to find out how you draw a row in MATLAB. I don't know, but I'm sure you will be able to find out. Okay. Then we do the same for loop. We do the iteration 2 to 20, and we update X naught. Okay, update it. Well, let me find out. Yeah, okay, that's the one. And update F naught also. Okay, that's the one. And end your loop for 20. Okay, and then plot again the same. Let's plot it all together. Okay, if not, and we are sure that it will converge. Okay, you see, very obvious. Okay, You see, you started at 2.5, so it goes up, then horizontal, then moves up, the horizontal, moves up, horizontal, moves up, horizontal, moves up, horizontal, until it reaches that point. The same if we start at a point, I'll show you 2 points. If we start at 6 and if we start at near 10, okay? Near 10, say around 9, okay? Let's do it again. Start first at let's say 6 or 7. 7 is okay. 6, okay? Let's say xx1 equal 6, okay? 6. Then we do the same for f of 1. We do the looping for, okay, for we do xx, okay, I want to practice that, and ff, okay, okay, and you end that, and we do that for x naught, okay, x naught, f naught, and then we do the updates of x naught and f naught, okay, x naught, okay, update, f naught, update. I want you to practice this on MATLAB, how we do it, and okay, and then plot, okay. You see, we have started at 6, okay, that's our start point. Then you move on that curve, then equal and move until you reach the solution. What will happen if we start somewhere here? It will move to this, or let's say around 10, say 9 point something. It will move to here, and it will jump from this point here to somewhere here in this region and start going there. There, let's do it, say 9.5, okay? Let's start xx at 9.5, 9.5, okay? And we find f1, okay, and then do the iterations for say 20 times, okay, and we update xx, that's the way we update ff, this way, okay, okay, and we end the iterations, and then we do the same for x naught, just we start x naught, you start f naught, okay, and then we do the update for, okay, k equal, so we update x naught, okay, we update f naught, okay, we end that, and let's plot it and see. You see, we started, watch, we started at this point here, okay, at this point we started, move to the curve, then move horizontal to the line y equal x, and then it will update to that region, okay? You could also sketch the iterations process. Let's look at what is x naught end. We know the solution around what. So this is 4 point, okay, 4.3125. If we want to plot the iterations, let's plot the f, okay, and see what happens. Okay, it moves the function, okay, to the solution. That's f, okay, and you can also look at f naught. Okay, it starts from a high place, okay, then comes and back to 4 point something, right? That's 4 point something. You can use a grid with it. Grid, okay. So you see that, okay, with a grid. So it's about 4. We started at high value, 9.5, and you come below 3, and then progress and divert toward the final solution. I think if you do that on X naught, it will be the same, almost. X naught, it's almost the same. You started at 0.5. So here you see this section, we are moving horizontal, vertical, horizontal, vertical, and so on. I think I could, now this is basis how we sketch the function and at least know the region of the convergence of a point, the region of the divergence of the other point. So at least you know how you will achieve convergence for one of them. That we call that the stable point. And then to find the other point, what you need is just to modify the function by multiplying it by -1 and adding to it 2x. So you'll get x, another function 2. And then you do the same process using this new function. So in this new function, the old points will reverse, the stable point will become unstable, while the unstable point will become stable. And in this case, you know at least you have two solutions for this function. One solution get it from the original function, and the other solution you get it by modifying the function this way. Okay. In the next video, I'll take another example on this fixed point, and I'll show you that probably even doing that, just multiplying by minus and adding 2x won't be enough. In that case, we need to scale it, do little something, and reduce the slope to make the absolute value less than 1, little bit, and then we'll be able to find a solution. The next video I'll try, I think I'll be able to increase the font. This font is not enough. I'll be able to increase it and make the font is higher. Okay, let me while we are here, let's try. I think it's home. You come to note preferences. I think, I don't know. No, it's not the preferences. It's somewhere in the setting. Okay, options. I think that we can change the font. It's not in here, but you try out and let me know how we can increase the fonts. Okay, I'll try myself, but let me know if you find out. After I will just within 1 hour, I'll try to upload this video on YouTube and send it to you. And once you learn how to increase the font, just let me know, please, huh? On our WhatsApp group, okay? So I will end up now the video, and I'll try to make the other video. If I can make it tonight, it's good. If I cannot, then I promise you tomorrow we'll make it. I want you to understand the fixed point because this is most confusing, not for you, my kids. It's in most of even UK universities, they find students, they find it difficult to modify this function. But we try to find solutions to these problems. Okay. One solution is, I found out just recently that you just multiply it by, so reverse it and you add, okay, and so on. Okay, I will talk to you later in the next video.